class. Today we are going to discuss some of the key concepts of our today's topic, which is elementary probability. But before we start, I'm going to first introduce my group members. That is I personally, Mchivi Derek, Sebuma Safan, and Suriji Mafias Makova. As we are discussing the today's concepts, the key concepts in probability, I'm going to take you through some of the key concepts. Suriji Mafias Makova will come in and also take part, as well as Sebuma Safan. And to begin with is our first mainstream, which is the definition of elementary probability. Elementary probability refers to the basic principles and concepts of probability theory, which is a branch of mathematics that deals with the likelihood of different outcomes in uncertain events. What does this mean? Here we are just seeing some concepts of probability theorem, and also just explaining to you that it is just part of mathematics that deals with just the outcomes of events or the outcomes of something. What is probability? That's another key concept, another key part of probability. Elementary probability. Probability is a measure of the likelihood of an event. Probability, we are just weighing the instance of the probability of outcome happening. Here, for example, what will be the probability that it will rain tomorrow? What will be the probability that your family will give birth to a baby boy or a baby girl? What will be the probability that this person will do this? What will be the probability that this and this? Some summary of our key events we are going to talk about today. Use the little mind map just to remind what outline our stuff. Here we are having sample space, which is going to be taken by me. Events and combining events which will be discussed by Suriji Mafias Makova, and conditional probability, which will be discussed by Sebuma Safan. Below is some of the chart that explains some of the keywords we use in probability. Here you are seeing also some figures we use in probability, for example, the die, the pie chart, but containing some objects. For example, when we are talking of the die, we shall show you how to use this die. When we are talking of a pie chart, we will show you how we are getting this pie chart, and still can be as thinner among others. Now here are some of our key words printed on our chart. We are having certain. When we are talking of probability and we hear this specific word in your question, over, or when you see this part anywhere in terms of in notes related to probability, just know here your probability will definitely happen. Still, when you see a concept that it is likely to happen, just know there the probability is going to happen. By all chances, the probability will come up. Then, unlikely to happen is the opposite of likely to happen. Here, your probability will not happen at all. Sorry, your probability will not happen. Then with impossible, just know here the probability is not going to happen at all. This is like as if telling a man to give birth. What would the theater order man to get pregnant and went to the theater. They actually has refused. Now let me go back to the point. Here, still it is some of my summary that is explaining to you that what I have explained above. For example, here the likely, the outcome. What does it mean? Our outcome simply means the possible result of a game or expectation or an experiment. Then likely, yeah, it will give an probability will happen, certain an event that will happen, unlikely an event that probability will probably possible, why possible, with impossible, the probability will happen or cannot occur. Then with probability, a number taking the likelihood. For example, what is the probability is we have that we can give birth to either a boy or a girl. So by adding the number space, as we're going to see from the space, just get the number of chances that you pass.
Could you please increase your volume? We aren't getting you well.
All right, thank you, Siriki Mafias Makoba. What of here? Are you hearing me?
Yes.
Hello, Mafias. Mafias,
Yeah,
are you hearing?
I get you now.
All right, thank you. Uh, Now below here is a video.
Yes, yes.
Are you seeing this link displayed on your screens?
Yes, we can see it.
This is one of the video that explains well the outcomes and the events happening. So by clicking in this link, we'll show you different ways and methods of how you can understand how to get the outcomes and the events and how to solve the probability. So by clicking here, you will see more and precious ways of understanding this part. Hope you click and watch later. Below, still, it is like a mind map that it explains well the occurrence or it measures, or it is a scale we use to measure probability. This is a basic terminology and rules. This is a basic terminology and rules. One, probability is measured on the scale of 0 to 1. We all know that our probability cannot exceed 1. Zero probability implies that there is no likelihood that an event to happen, while a probability of 1 indicates that an event is certain to occur. Then it is well elaborated. From 0 to 0.1, what chances are we having there that the probability will occur? There we are seeing 0 chances at 0. Here our probability is not certain. Here our probability will not occur. Here our probability is impossible. We don't expect to see any probability here. Then we come, what will be our likely, unlikely? With our unlikely, here the probability will be at 0.25. Here it implies that we are having a little bit of our probability and we are having few chances that this probability will occur. Then from there, come to 0.5. Here we are having now 50-50 chances of probability to occur. Here, there are even chances that this probability is going to occur. What does it mean? There is equal chances that the probability is occurring, or there is equal chances that the probability is not occurring at 0.5. Then at 0.75, here the probability is likely to occur at all costs. We will receive probability in percentage that will be 75% chance that this probability is going to occur. That means that our probability here is possible. Then at perfect 1, here the probability is certain. We are quite sure that our probability will occur at all costs. For example, a mother gets pregnant. What is the probability that she will give birth? Our probability there, it is 1. By all means, whether she gives birth to a dead baby or a live baby or aborts, there are all chances that is by all means this by all chances that this is going to get out, that the fetus is going to get out of the mother's womb. So there, that implies that our probability is perfectly 1 by all means. Then when I go to the second part, this is going to just explain to you how to get our sample space. In a summary, here you are seeing sample space diagrams. In these sample space diagrams, I used the 2 dies of different colors, one of red, another one of blue. And in drawing my sample space diagrams, still I use different colors to identify different dies. For example, the red die, I used different labelings of my numeric values. And the blue die, I used the blue color to represent my numeric values. For example, I'm going now to toss my dies together to get the sample space that I will use to determine the probability of these 2 events happening. So I will toss my die. By tossing, I will see that at the first point, I can get 1 to 1. By adding 1 to 1, I will get 3. By tossing, in my first step, I can get 1 to 1. My blue die can display 1, and still my red die can display 1. Still, my red die can display 2, while my blue die has displayed 1. There, I just add this number to this number to this number to this, in this space, getting the sample space there. Here, then after I add all my sample spaces here, and I get the total outcome of this. Then from this, someone will ask, what do I understand by the term sample space? Understanding by the term sample space is simply a total number of events happening. Sample space is it implies just simply a number of total events happening. As I told you, the probability that a family will give birth to either a baby girl or a baby boy. You are having now 2 events that a baby can be a boy or can be a girl. So adding the boy and girl as your outcome, that means it is your sample space. Your sample space will be 2, since you're having 2 outcomes with the 2 chances. Then from those chances, they're asking you, there is just 1 chance that over that 2 outcomes, 1 outcome will happen. Are we together?
Yes, we are together.
That's one of the part. That is one of the way we are getting our sample space. Just it is easy, simplify, understand, and know how to get it in that way. Thank you. Thank you. Let us go back. My networks were not stable. Let us go back now. Starting from where we had stopped. I have been explaining to you how we get the sample space, which I think you are all conversant with right now. Are you all together? Do you all know how to get sample space right now?
Yes, we can.
Good. Mafias. Mafias.
Yes.
Mafias.
Yeah, I'm getting you. My network is not stable, but I'm getting you.
Mafias, do you know how to get sample space now?
Yeah.
All right, that is good. Now this is one of the work example showing you how we can get the sample space and how to use it. It states the spinner is spun once. Find the probability of each event. Write each answer as a fraction, comma, percentage. Then, by looking in this diagram of yours, I told you with sample space we get the total number of outcomes, or the total number of events. Now let us count together to find our sample space. I will start from A, B. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we know it is now 10, our sample space, which you are seeing here. But they have asked you the probability that F, probability of F, then come and look in this spine of yours, find where F is and count the number of times you are seeing this F. You will see that you are seeing only once. You are seeing it once. That means it is 1 over the total sample space, over the samples, the total events you are having, which is 10. Then that will give you 1 over 10. Then still they told you can still find the probability of D or G. Come find where there is G and come find where there is D. Here you count. I have 1 and I have 2 here. There are 2 events. Then over the total number of events, which was 10, getting this 2 or over 10 of yours. This is a trial question for you, my learners, to continue with. From there, I call next discussant, and that is Sergi Mafias Makola, to come and explain the term events and combining events, who will later call who will later call Safan Sebuma to conclude with conditional probability. Sergi Mafias, you are most welcome to this discussion.
Okay, Mr. Siriji Masias Makowa, we are waiting for you on the floor.
Yes, thank you so much. I'm going to be discussing about events. I don't know. Are you guys getting me? No.
Getting you, and we are running out of time.
Okay, I'm going to be discussing events, and by definition, an event is a collection of possible outcomes of a random experiment. Given a number of events, like can be mangoes, oranges, can be figures A or B, and we are asked to find out certain quantities that or something that we need from the events. We are going to look at a subset E of an outcome. That is what we call an event for E. Probability of events, the basic formula. The basic formula for probability of events is that formula below that talks about the total outcomes in the event over the total number of outcomes in the sample space, which are all represented by n in bracket capital over n, which is number of events and then over the total sample space. And an example is that is below. We can move on to the next slide. Safan, could you please take me through the next slide? Yes, there we are going to be looking at the probability of two events, and we are going to look at define the two events can be, say, let's say they are A and B. The formula for that is the probability of A union B is just the sum of the probability of A plus the probability of B. And when the two events are said to be mutually exclusive, it means that the probability of A intersection B is often said to be 0. But now when A, that's why it's not there in that first equation. So below we have the probability of A union B equals to P of A plus P of B minus P of, which is not mutually exclusive, which means the value of P of A intersection B is not equals to 0. And then we have the second part there in the middle where we have the intersection of A and B. An intersection is that set that has events that are both in A and both in B. And we can easily get those intersections through the multiplication, where we have the probability of A intersection B being the probability of A times the probability of B. When these events are independent, it means that is what we get. But when the events are not independent, we shall have the probability of A intersection B being the probability of A times the probability of B given A. And then the exclusive OR of A and B. That is also given below, where we shall have the probability of A plus the probability of B minus twice the probability of A intersection B. Safan, could you please move to the next slide? Now here we are going to look at combining events, and this involves getting a number of a random sample of of outcomes like green, red, or yellow, blue, white, name them but a few. And combining events basically refers to the process of merging or integrating multiple events or activities into a single cohesive experience or occurrence. A counter is taken at randomly from the bag. Here we are using counters. Sometimes it can be coins. Safan, could you please lead me to the next slide, please? Hello, Safan. Are you there?
Yeah, we are here.
Hello.
Yes, I think we are done with combining
Next slide. Next
events.
slide.
Yeah, I think we are done with combining events. Now we are going to
Yeah.
conditional
And
probability,
the
where
next slide we have the sample space diagram for two outcomes, strokes, spinors. Yes, Derek, are you saying something?
yes,
What's up?
yes, I have been telling you that the combining events they are done. I think now yes, Honorable
Yeah,
Safan is
Safan,
coming.
could you please?
Start. It should come and start from here with the conditional probability.
Okay, good evening, everyone. My name is Seuma Safani, as already mentioned, and I'm here to discuss or take you through condition probabilities. And in this case, we mean a measure of how likely an event is to occur based on the current event. In this case, if we talk of conditional probability, that means that there is something that has to take place given there is also another condition still affecting the first condition. For example, if you look at our picture here, in the picture we have a condition, we have an event A and an event B, but for the event B to occur, A must have been occurred. So in that case, we are meaning what we call conditional probability. And for this case, we have this nice picture. It is illustrating. It has some good words like my love for you is unconditional, probably. So in this case, it means that he loves